Hello, I will be covering a LR set of CAT 2022 Slot 3. This will give you an idea of how we explain LR sets in our DILR self-study course. The link to the course is in the description below. You could pause and read through it at leisure. I am going to read it very fast and only the salient points to keep the length of the video short. So there are 4 people, PQRS, they participated 8 rounds, they are forming 2 pairs and each one is in just 1 pair. So 4 people, they get divided 2 year, 2 year. The restriction is that the pairs would change. And if explained, so P and Q are there in the first round, then he would have to form a pair with R or S. Right, he would necessarily have to change in the second round. He would be free to pair with Q again in the third round onwards. And that's very logical also. So if you form the pairs, there are actually only 3 pairs that can be possible. P with Q, P with R or P with S. Whereas there are 8 rounds. So obviously some pairs are going to be repeated, right? So, but they can't, but in the immediate next round, it should change. Now, in each round, each pair decides whether to play that game in that round or not. If they decide not to play, then no money was exchanged between them. So it takes a little effort to understand here what's happening. So the pairing thing is easy. Now take a pair. Now they'll decide, should we compete or should we play or not? If they don't, then nothing happens. No one exchanges money. But if they decide to play, they would bet 1 or 2 in that round. And if they chose to bet 2, then the player winning the game got 2 from the guy losing the game. And this is talking about each pair. So let's take the first pair. They decide, let's bet 2 rupees. So one of them will win, one will lose. So a 2 rupees. One of them stands to gain 2, one of them stands to lose 2. And the same thing happens in the other one independently. So they might choose to not play or play 1 or bet 1 or bet 2, right? So that is the understanding. The set continues. At the beginning of the tournament, the players had 10 rupees each. So that's important, 10, 10, 10 each. Now here, there's a very interesting thing that comes before you go ahead with even this table. You know what? The money is only being exchanged between them. So if the money is being exchanged between them and each had 10 at the beginning, then at any stage, no money is coming from outside, nothing is going outside, it is only a redistribution between them. So the sum has to be 40 at any given point of time, right? Unless there's something to the contrary. The following table shows partial information about the amounts they hold at end of each round. It shows every time that a player had 10 at the end of a round, as well as every time that at the end of a round a player had either the minimum or the maximum. So this every time is very important here, students. Okay, and that is also further explained clearly. For example, Suresh had 10 at the ends of round 138. Suresh 138, and importantly, and not after any of the other rounds. So you cannot put a 10 anywhere. So this is the only instance Ritesh has a 10. He cannot have a 10 anywhere else, right? So obviously the blanks are the one that you need to fill in, right? So you can't fill in a 10. Just remember that. The maximum amount that he had at the end of any round was 13 at the end of round 5. So 13. Okay. And the minimum amount he end was at 8. So 8, the minimum is also given. Okay. And this is any time, every time that he had the maximum or the minimum will be mentioned. So here 13 is mentioned just once. So he had it only once. If I look somewhere else, like look at Pulak, 13 and 13. So these are the only instances when he had the maximum, that is 13 every time. So the rest of them cannot be again equal to, they have to be less than the maximum. If the maximum is repeated, it would be present over here. The same goes for the minimum. So it continues and explains. So the minimum is 8. So you can't have a repeated 8 or else it would have been shown. So you can only have a 9 or a 10 can't be there, 11 or a 12. That is what this is written. Further, don't forget, usually in this long list of data, we miss out that it is also known that P and Q had the same amount of money at the end of round 4. So, having seen it, we have to reconstruct the table, right? Obviously you can't draw it on the screen, you will have to make it on your paper. So I am also making it on the paper, and so let me do the complete thing instead of just having a ready-made table. And don't forget that at start they all had 10, so I would even add that to the table. And now the rounds commences, okay, the different rounds. So I'll have a round 1, I'll leave a little space, 2, 3, 4, okay, a little gaps just to say what is the change, 5, 6, 7 and then 8. So this is the 8 rounds done. Before I go ahead, let me just copy what is given over there. Round 1 is 8, 10, 10. Okay, and when you copy, you realize, oh, 3 values are known, and you know the summation of each row has to be 40. Nothing to the contrary was given, right? They just redistribute the amounts among them. So I know this value. You might be tempted to write it, and it's okay, but I want the minimum and the maximum as given in the table. So I'm just copying the table as it is right now. Later I'll do all this work. So that's 13, 10 and an 8 in round 2. Is that 13, 10, 8? Yes. Round 3 values again, fourth can be found. In the third round, there's only a 10. So third round is going to be a little issue. Fourth round is completely blank. But don't forget that there was a clue for the fourth round, and usually student one might forget this. And what is that clue? P and Q are same after 4 rounds. Yeah, so that's an important one, don't forget. Yeah, what's there for fifth round? 10, 10, 13. Oh great, so 3 values are known, 10, 10 and 13 is in the last. Okay, so I can see that the last column is being populated quite a lot and the third column is not being populated. Sixth is again completely empty, it's going to create a problem. 7th is 12 and a 4, and the 8th round is 13 and a 10. 13 and a 10. So I've got all of this. My first things as explained in that instructions. The minimum is 8, maximum is 13. You can't use them or 10. So you could only use a 9, 10 or 11. 9, 10 or 11. No, sorry, not a 10, 11 or a 12. Right, my mistake. Let's see for R. The minimum is 4, the maximum coincides with this 10. Since nothing else is given. Yeah, you need to have that conviction over there. So the values that you could end up using is a 5, a 6, 7 or a 8 or a 9. Nothing other than this. So that is a little disappointing. We have lots of possibilities there. Here 8 is the minimum, 12 is the maximum. So I can use a 9, 10 will already been put up if it were there. So I will not get it, and 11. That's it. Also just 2. So this will help me, right? See where attack. The rows and this column will attack. This column also quite a lot is filled. Let's see here. Same way, just as we had the maximum that 10, here the minimum is 10 because there's no other value. Okay, so minimum is 10, so I could start from 11 and 13 is the maximum, 11 or a 12. So just 2 things. So now for the answers, right, of our contribution to the table, the first thing is this clue. Do you see these two have to be same, and this can only be a 9, 11 or a 11, 12. So the only thing they can be is 11 and 11. So this blank row has now 2 filled in. So 2 is decent. So there are a few possibilities here. We'll work that out, right? The other thing is the low hanging fruit. Let's add this up. 10, 10. So this should also be 20. So this has to be a 12. 13 and 10, 23, 31. So this has to be a 9. Oh, great. So here 2 left, here again I can fill in 20. So this should be 20. So this should be a 7. Now this row has 2, this has 2, this has 2. So let's tackle that. 22. So here I need a 18. Okay, and an 18 with only these numbers possible. So I'll start from the one having less possibilities. So 18 I want. A 9. A 9 and a 9. Is that a 9? Yes. But the moment you put a 9 here, now we are building the logic a little more. Remember we said this column is filled quite a lot. So he loses 2 rupees, he gains 2 rupees, he loses 1, a 9 is possible. But from 9 can you jump to a 13? From 9 to a 13 in one round means an increment of 4, which is not possible. So the 9 cannot be used there, students. Yeah, so that's another logic that got built up because we were not using that 0, 1 or 2 so far. Okay, so the 9 is not possible. 10 cannot be the 11. 11 and what? 18 you want, 7. Now the moment you put a 11 over here, just imagine, don't put it, it's difficult to erase when you write it. So 11 and this will be 7. The striking thing should be 7 and 7, they are same. So that means R did not change his money. So R did not participate. So his partner also would not. But 11, if 11 has changed, this has changed, this has changed, but how can this not change then? If two things have not to be changed, then there are going to be two numbers which don't change. For example, okay, we don't have it as yet here. Here we have, right? R doesn't change, S doesn't change. They are a pair who doesn't, right? So, but here, so just a single 7 not possible. So 11 is also not possible. So 12 has to be the case. 12 and 6 will make it a 18. And now if you wonder, let's see, we'll do with that plus the 12 has become a 13, so he loses a -1. 6 has become a 7, he gains a +1. 11, oh, is this also gain? My mistake. Yeah, 12 has become a 13, he gains a 1. This guy loses a 1, this guy also loses a 1. So is a pairing possible? Yes, the losing one can pair with either of the gaining ones. Right? And so a pair is possible. Okay. So now we'll have to use things like this also, right? Because the low hanging fruits are already done. So let's look over here. 12 and 4 is 16. So the other two have to add up to 24. That's a decently large number. 11 would make a 13. There's no 13. So this has to be a 12 and a 12. Also, this also row turned out to be very easy. Now, there's an interesting, okay, let's see, 3 12s are there. We will see it later, right? Let's see. Okay, so how about the last row? 10 and 13 is 23. 23, 17. So these two should add up to 17. This is 9 and 11. Now 12 can't become a 9. You can't lose 3 in one round. So this has to be 11. And if it has to be a 17, this has to be a 6. Okay, and you want to do a check, we'll do. Right now we have to fill in these two rows, then later on we'll anyways check. So do this 12 plus 13 plus 1, 12 minus 1, 4 plus 2 and a minus 2. So let's look at that pairing also. And in pairing again you can do a little efficient work. Do you know P will always be paired with someone? So I'll just write who is P paired with. Okay, and once I know P is paired with whoever, the other pair is already known to me. So I don't need to write it. Also, if P changes his partner, then the other one will also automatically change, can't remain the same, right? So once P changes, everything will be taken care of. So here look at who is P participated in the 8th round. +1 has to pair with the -1. So P has participated with Q and the other two have participated, right? For 7th round, I would need this 6th. So we have to just fill in the 3rd and the 6th round now. Okay, so let's see quick. Now, the advantage from 2nd to 3rd round is I know that this is a +2. 8 to 10 is a +2. So someone should have a -2. So let's start from the immediate. Can this be a -2? So this could become a 7. Is the 7 possible? Yes. Now look ahead also. Can the 7 become a 6? Yes, a -1 is possible, right? So it is turning out to be possible. So what you could do is, you know, you could go away and make a sub case of 2nd, 3rd and 4th just, right? So 2nd is 3, 13, 10, 9 and 8. Okay, the 4th one is also known to us, 11, 11, 6 and a 12. And this is known to me. And now my guess is this +2 was paired with this guy and this became a 7. Okay, so that is my idea. Okay. Fair enough, this looks good enough. Now think ahead. Now this 10. Okay, so is this a plus? Yes, this is a +2, this is a -2. So these two should pair with each other sort of with my assumption. This is my assumption. Okay, so I mark my assumption. Now, if I look at 13, 13 is the maximum. So do you see that 13 has to decrease? It can't increase. And if this is decrease, the 10 has to increase. And if 10 increases, the only possibility is increase by 1. 10 increases, increase by 1. And if this increases by 1, this should decrease by 1, right? So this is going to be a 12. So there everything looks okay from second to third, but if I go from third to fourth, do you see this is an increase of 2, this is a reduction of 1, this is 0, and this is a decrease of 1. So you can't have such a thing. You can't have one of them 0. At least 2 should be 0, right? So this assumption did not work. Okay, so the decrease 2 is not possible. Can a decrease 2 be possible here? 8? No, 8 is not possible. Can a decrease of 2 be possible? Yes. So this will be my answer if this can't decrease. This is the decrease of 2. Now if I look at these, do I know for sure R has decreased from 9 to 6? A 2 or a 1 has to decrease. So if this is a decrease, this guy has to be an increase. These two have paired. If this is an increase, he can only go to 11. So this is an increase of 1. This will be a decrease of 1. So this becomes an 8. So this 2 to 3 is good enough. Let's see 3 to 4, is it good enough? There's no change here, there's no change here. Is there a decrease of 2 here? Is there an increase of 2 here? Yes. So everything is good enough. Let's look at the pairing also. Here who had paired? Okay, I need this one. This is a -1, this is a +2. Oh, this is a +1. I'm making that error. I don't know why. 12 to 13 is a +1, +2. This is a -1, this is a -2. So P would have paired with R. P would have paired with R. What's happening over here? -2 and a +2. So P would have paired with S. What's happening here? P would have paired with Q. So is everything okay in order? Yes. So that's good. And that same thing now you do for sixth one. So ideally you should pause it and do it yourself. Here you had a +2 start, but here you don't have any start. Okay, but you still have something over here. What is it that you have? You have the 7 has become a 4 at a drop of 3. The only way a drop of 3 can happen is when you have a -2 or a -1. Order might change, but there has to be a -2 or a -1. And now pay attention to one interesting fact. Now this is deep insight. I don't think so this can work. But if someone had if this was a, let's say, a decrease of 1, then I would have a decrease of 2 here. If this was a decrease of 2 from here to here, then in one of the remaining 3 columns, there should have been an increase of 2 and an increase of 2 and becoming 12 is not possible. Why? That means the previous score should have been 10. But if it was a 10, it would have been written over there. Since it's not written, right? So this can't be a -2. And if this can't be a -2, this can only be a -1, and this should be a -2. So this will become a 5 and then this one, right? And if this is a -2, look at how easy it is. This can't be a +2. You can't have anything more than this. This can't be a +2. You can't have a 12. Can this be a +2? Yes. This will be a +2. So there you have your -2 and this. Now look at 10 and 13. 13 has to necessarily have a minus. Okay, and hence 10 necessarily needs to have a plus. And if 10 has a plus, the only thing it can have is a +1. This becomes 11. So this will be a -1. 13 minus 1 is a 12. Oh, I get a 12 and a 12. So is that okay? Yes, I have a 12 and a 12 here also. Nah? And this is a +1, this is a -1, this is a 0. So let's mark out. So 0 and 0. P again pairs up with S. Here P has a +2, a -2. So P pairs up with R. And last, let's finish this also. Here the negatives could have paired with anyone. So P could have paired with R or S. But R is in the next round, so it can't be here. So this has to be with S. So the pairing is also pretty much found. The whole table is filled up and the questions would straight follow from the table.